Alright, we're examining deep into the OSI model, Open Systems Interconnection, and TCP IP model, Transmission Control Protocol, Internet Protocol, layer by layer, but don't worry, it's going to feel more like a TED Talk than a classroom snooze fest. So make sure to like, subscribe, and don't forget to hit the notification bell. The OSI model, Open Systems Interconnection, is a conceptual framework that standardizes the functions of a telecommunication or computing system into 7 distinct layers. It helps different systems communicate with each other by breaking down complex processes into manageable stages, from the physical transfer of data to application-specific tasks. 1. Physical layer. This is the most fundamental layer. Think of it as the road for your data. The physical layer converts raw data into signals like radio waves or light pulses. It's where ones and zeros start their journey. Just move. No meaning yet, just motion. Example, those Wi-Fi signals you're using right now. That's the physical layer at work, sending ones and zeros through the air like little race cars on a data highway. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 2. Data link layer. Now that the data's moving, it needs a traffic cop. The data link layer ensures that frames of data know when to go and when to stop. It's also responsible for error detection and correction. Example, your device's MAC address? It's like a street address, ensuring data reaches the right place. This layer guarantees no data collisions, smooth flow. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 3. Network layer. Next, your data needs a GPS, the network layer. This is where data gets an IP address and figures out the best route across networks to reach its destination. It's like Google Maps for your data. Example, when you type google.com, the network layer uses IP addresses like 192.168.1.1 to navigate your request across the web. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. The transport layer is like a mail service. It breaks down your data into packets and makes sure each one arrives safely. TCP makes sure all pieces are in order, while UDP is all about speed. Example, Netflix without buffering? That's TCP. Or playing online games with UDP, where speed is key, even if a few packets get lost along the way. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 5th session layer. Think of the session layer as the meeting organizer. It sets up, manages, and closes the communication session between two devices. It makes sure your session stays open while you browse. Example, logged into Facebook? The session layer is keeping your session alive, so you don't have to log in again every time you click on a new page. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 6th presentation layer. This layer is your translator. It ensures data is in a readable format, handles encryption, and makes sure it's properly displayed to you. Example, watching a video? The presentation layer makes sure the MPEG format streams smoothly. Using HTTPS, it's also encrypting your data for security. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 7. Application layer. Finally, the application layer is where you interact with the data. Whether it's your web browser, email, or social media, this layer makes sure the data is presented in a way you can use. Example, using Chrome to browse or Spotify to stream music? That's the application layer at work, making everything functional and accessible. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. The TCP/IP model, Transmission Control Protocol, Internet Protocol, is a more streamlined, practical model used primarily for the Internet and similar networks. It defines how data should be packaged, addressed, transmitted, routed, and received. This model consists of 4 layers. 1. Network Interface Layer. The network interface layer is the hardware side of things. It combines the OSI's physical and data link layers, ensuring that data moves from your device to the router. Example, your Ethernet cable or Wi-Fi. Yep, that's all here, making sure your device stays connected to your local network. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 2. Internet Layer. This is where the IP address magic happens. The Internet layer handles the addressing and routing of your data so it can travel across networks. Example, every time you visit a website, the Internet layer uses IP addresses to route your data, just like sending a letter across the globe. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 3. Transport Layer. In the TCP/IP model, the transport layer is still responsible for breaking data into packets and ensuring it gets delivered, whether through TCP for reliability or UDP for speed. Example, watching YouTube, TCP ensures everything's in order. Gaming online, UDP sends data fast, even if some packets go missing. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. 4th, Application Layer. This layer covers everything from your apps to services. It combines the OSI's application, presentation, and session layers into one, making sure the Internet is useful. Example, whether you're using a web browser, an email client, or streaming video, the application layer makes sure your apps can talk to the network. It's quiz time. Test your skills and knowledge on this layer, then check your answers at the end of the video. And that's it. Now you understand what's happening every time you connect to the Internet and how each layer makes sure your data gets where it needs to go. Each part of the machine works together to ensure data travels fast and smooth.